Assalamualaikum and welcome. We are from Group 16 and today we want to present about our topic which is compressed air energy storage technology and our lecturer is Dr. Khairul Anwar Ibrahim. Before we start our presentation, we want to introduce our group member which is uh, BS Muhammad Zulfazli bin Muhammad Razi. And my magic number is B0819103116.
And my name is Ahmad Ashraf bin Ahmad. My metric number is P0819103330.
Hi, my name is Muhammad Aswad bin Alwi and my metric number is B0181910023.
Okay, so our topic is compressed air energy storage technology. Compressed air energy storage, or as known as KS, is a technology that stores energy as compressed air for later use. It is technique for supplying electric power to meet peak load requirement of electric utility system. KS is one among of other storage plants like flywheels, battery, and superconductor. KS is also a combination between pure storage plant and power plant that consume fuel. So the components that used in KS is intercooler, compressor, clutch, motor or generator, turbine, combustor, valve, and cavern. So how it works? Compressed air energy storage use surplus energy to compress air which is then stored in underground reservoir. The compression of the air generates heat. The air can be released to a combustor in a gas turbine to regenerate electricity. How does it produce electricity? In conventional compressed air storage, electricity is used to compress air, which is stored in underground caverns. That air is then released to drive a turbine generator to produce electricity when needed. Such storage costs roughly a tenth of what battery storage costs, but it isn't used much because in large part it requires a location with underground storage space. Sustain system eliminates this problem because it can efficiently use above ground storage tanks rather than caverns. So this picture show how the process first excess of peak power is used to compress air, then it flow, the air is pumped underground and stored for later use at the cavern. The third, when electricity is needed, the stored air is used to run a gas-fired turbine generator. Then the electricity produced is delivered back onto the grid. Working principles and processes. There are three processes: compression, air storage, and expansion process. Compressed air energy storage plants are largely equivalent to pump hydro power plants in terms of their application. But instead of pumping water from a lower to an upper point during period of excess power, another gas is compressed and stored under pressure in an underground cavern. When electricity is required, the pressurized air is heated and expanded in expansion turbine driving generator for power production.
So, what is the benefit of compressed air energy storage? So, one of the benefit is increased energy savings. It also enhance air quality and improve system stability. It also reduce maintenance costs and extended air compressor lifetime. If there is a benefit, there must be a cons or what we call a disadvantage of compressed air energy storage. So one of the disadvantage is economical only up to a day of storage. It also requires sealed storage cavern 24. The case is not yet fully developed and the requirement for additional heating is high. So one of the location of power plant for compressed air energy storage is at National Renewable Energy Laboratory in Colorado, USA. So about the facility is an energy production and energy storage system. The Northern Kais Energy Production Facility operate by using off-peak electricity available at night and on weekend. Compress air into the storage vessel. During the intermediate and peak demand periods, compressed air is released from the pressure energy storage system heated by the combustion of natural gas and used to drive high efficiency turbines to produce electricity. Using electric power compressors, injecting the air through dedicated wells charge the storage vessel. Air free flow from the mine to the energy production system. A KAIS facility consists of an energy production and energy storage system. The Northern KAIS power plant facility will operate by using off-peak electricity available at night and weekend to compress air into the northern mine. So during the weekday time, intermediate and peak demand periods, compressed air will be released from the pressure energy storage system heated by the combustion of natural gas and expanded through the energy production system.
For the standard and regulations about KAIS. Firstly, reporting. Report should plan well, overhaul and inspections and the result of such inspections includes copies of all of the sonar survey, log, test data and the interpretations of this data. Second, posting of well license. The operator shall post a copy of the well license at the well site during all well drilling, overwork or service operations involve a drilling or service rig. Okay, next. Next is land ownership or lease arrangement. The application shall include confirmations to the ministry certifications that the applicant has the surface, mineral and compressed air storage right through ownership or lease for all lands on which KAIS work will be located. And the fourth standard, which is project descriptions. A project description shall be prepared and submit with the applications. The locations descriptions includes local and upper tier with municipalities, lot concretions, geographic township and civil address. And the fifth standard and regulation is risk assessment. A risk assessment shall be conducted in according with clause 7.1 of CSA Z341.2 with specific reference to compressed air parameter and submit as a part of the applications. The assessment shall consider the life cycle of the proposed operation from start up through the decommissions, decommissions and abandonment. Okay, this is our reference that we find our to make our slide. Okay, that's all from us. Thank you.